Hey guys, today we're going to talk about this CPU. Now, this is an i5 3330. So let me see if I can focus that so you can see that. I think that's pretty clear on the camera there. So this is an Ivy Bridge third generation core processor. Now, the launch date for this was quarter 3 of 2012. So in September of 2012, this was released. And I'm recording this video in April of 2025. So this is a pretty old CPU. Now, I dug this out of my closet for a budget build that I have coming up. So I'm going to be using this to, scrape together some spare parts just to throw together, a machine using some spare parts and stuff. So I'm going to have more on that and covering the other parts coming up in a little bit in a future video. But we're going to talk about this CPU today. So the socket supported for this is FCLGA 1155, and that's basically the same. FCLGA is the same thing as LGA 1155. So this is a socket, also called a socket H2, and it has a thermal spreading solution specification of 2011D. That the 2011 doesn't stand for the date apparently. And you'll see over here I actually have the I have the heat sink. So this is the stock heat sink. So this part right here would go on the CPU right here. So I actually cleaned this up, removed all the dust off of it a long time ago before I stored this in the closet. This is the fan that goes with it. Fan clips over it like that, goes onto your motherboard, right? So this is the heat sink and fan that comes with it. It's the stock Intel cooling solution. So anyways, let's talk about some of the specs of this thing. And I mentioned that this is FCLGA. So FC just stands for flip chip. So it's, flip chip land grid array, or FCLGA 1155. So LGA 1155 is the common name for the socket, and FCLGA 1155 is the technical term for the physical CPU package. They're the same in terms of compatibility. Those are basically the same thing. They just use different terms depending on what you're referring to, but they basically mean the same thing in terms of compatibility. So anyways, this CPU is a 64-bit processor, obviously. Has total cores, 4 total cores and 4 total threads. So 1 core per thread. So there's no hyper-threading. Now the base frequency is going to be 3 gigahertz, and the max turbo frequency is 3.2 gigahertz. I basically never, I'm never going to be using that, so I'm just going to stick with the base frequency. I don't overclock stuff, so that's just for me. But if you do overclock things, you're probably not going to be okay with the stock heat sink, and that'll probably matter to you. It doesn't so much matter to me. Anyways, we have an L3 cache that is 6 megs, and it's an Intel Smart Cache. No, an Intel Smart Cache, that's just the name for a shared cache. That's the Intel name for a shared cache. And the cache is going to be shared between cores. So all the different cores on this share the same L3 cache, which helps for efficiency. Now on this thing, there are 3 caches. There's the L1, L2, and L3. The L1 cache has 32 KB per core for data and 32 KB per core for instructions. Now the L2 cache has 256 KB per core, and the L3 smart cache has 6 megs shared across all cores, right? Now, the thermal design power, or TDP, or also called the thermal design point, um, 77 watts. Now, this is the max heat that it will generate and that needs to be dissipated by the cooling system. This is for normal operation at non-turbo clock rates. So, also, so leading into, power consumption, right? So that loosely relates to TDP. So it's loosely based on, the heat is loosely based on the power consumption. So idle, this is going to consume around 10 to 15 watts. Average load, like say gaming, is going to be 40 to 60 watts. And full load, like think stress test or whatever, it's going to be closer to that 77 watts. And, maybe slightly more depending on, your exact system and the specifics of what you have set up, right? So that's what we have there. We're still sticking with the base heat sink, right? Now, bus speeds, 5 GTs per second. I'm not going to get too much more into that. So memory types. So it supports DDR 1333 slash 1600. And I believe it would support others that if you're going to overclock them, but those are like the base supported memory types. And there's more on that when we talk about the motherboard that we're going to match this up with, but the motherboard is going to be in the next video, not in this video. Now, max memory size depends on the memory type, but the max memory size that this supports is 32 gigs. So you can only have a system up to 32 gigs with this, which was kind of overkill. It was a lot at the time, back when when this chip came out. These days, it's going to, depending on what you want to do, but for what I'm going to do, that's sufficient, I guess. So max number of memory channels is 2. So you have dual channel memory supported, and the motherboard this goes on also has dual channel, which is pretty common. Max memory bandwidth is 25.6 gigabits per second. ECC memory is not supported. Now, this has PCI Express revision 3.0 and PCI Express configurations up to 1x16, 2x8, 1x8, and 2x4. So, but those are just the configuration supported. Not super interesting to talk about when you're just talking about the CPU, but more when we look at the motherboard, right? So, some notable features. Includes the virtualization features that you would expect. I figure these are worth mentioning. As Intel virtualization technology, or the VT-X, and Intel virtualization technology for directed I/O, VT-D. What else? So also Intel VTX with extended page tables, or the EPT. And another feature this has is the execute bit security feature. So you can execute disable bit security feature. So you can disable execution of certain things, and what that means is that certain sections of a running program can be made unexecutable. This makes it so that certain malware exploits can't be run, so that executable code can't be loaded into a data section of your program, into like a data section of your memory. So like viruses and exploits and hacks, stuff like that, can't be loaded into one common thing that malware will do is load code into a section of memory that's meant for data, and they'll cause it to execute. And if you can stop it from being able to do that, you can pretty much cut short a lot of security risks. And that's one of the features that this has. So that's kind of a nice feature to have for security purposes. More and more standard these days, right? Now, in terms of the GPU, this does have a built-in Intel GPU. And I wish I could hold this at at an angle where you could see it, like the light keeps shining off it. Anyways, yeah, so GPU, it has an HD 2500, or the Intel HD Graphics 2500, and it supports supposedly 3 displays. So the GPU that's built into this supports 3 displays. Now, not all of these core processors have a GPU built in. This one does. So if you have a motherboard that and you don't have an external GPU, this will you can still just plug in your monitor directly to the motherboard, not into an external graphics card, and this will work as your GPU. So that's actually what I plan to do. I pulled this out of a system that had a GPU, but I'm not planning to use the GPU with the new system I'm going to build from the spare parts, because I'm not using it for gaming or a workstation or anything. So I'm just going to use onboard the onboard GPU in this chip, because I'm not doing a whole lot with the GPU in this new build, and I'm going to kind of try to make it more compact and streamlined. So I'm going to make use of that, but I wasn't using this in the system that I pulled this out of. Anyways, just wanted to share that with you guys. If you like PC hardware or hardware in general, and you think this kind of stuff is interesting, and you want to see more of this, make sure you hit that subscribe button. Also, you're going to want to go hit the bell icon so you actually get alerted when we come out with new videos. We have a lot of great videos coming out. We're going to be doing more hardware videos. I'm going to be going over the motherboard and the power supply and some other stuff that I'm going to use for this build. And I'm probably going to, once I get the build put together, once I get around to that, I'm going to probably review that and show you I'm planning to build like a custom case, but we'll see how that goes. We got a lot of great tech stuff coming up. We do a lot of like hardware, software. We do everything from like programming and automation, coding, networking, 3D printing, Raspberry Pis, robots, electronics, hardware, software, all that great stuff. If you like that kind of tech stuff in your YouTube feed, definitely hit the subscribe button and hit the bell icon. Also, might want to give me a thumbs up for this video, but also leave a comment down below if you've used something similar to this. Let me know what you think about using something this old, and under what circumstances do you think it's okay to use something this old. It does, when I actually look at the date this came out, I mean, I know this is pretty decent power for what I'm doing with it, right? But it's pretty weak compared to modern. It's incredibly weak compared to modern CPUs, and it's only an i5 to begin with, right? So you know, under what circumstances is it okay to use something this old? For my use case, I think this is going to be okay, but let me know it down in the comments. What are your thoughts? But that's about it for today. So you know, as always, thanks for watching, and we'll see you guys on that next video.